All right, so we know how to deal with linear systems. We know about graphing, we know about the substitution, we know about elimination. The question now is, if we're given a linear system at any point, which method should we use? This video is just going to describe that decision-making process, and I'll tack these both with both methods to talk about it. First and foremost, I said both methods because this, graphing. Let's just talk about the idea of graphing a linear system. The idea is you're going to have some axis here, and your job is going to be to graph one of these linear equations and then graph the other linear equation. The solution to that system is going to be the intersection. Here's the deal. If that intersection is a decimal or a fractional answer, good luck unless you're some person I've never met before in finding that exact solution with this method. Not only that, graphing generally is convoluted and prone to lack of accuracy when you're drawing your lines. So right out the gates, I'm just going to say this. Unless you're asked to solve a system of linear equations with graphing, or you're provided a graph with the system, never voluntarily solve a linear system by graphing. Honestly, the only reason that we use that as instructors is to provide the concept of linear systems. You would never use graphing to solve a linear system. So we've gotten that out of the way. Now should we use substitution or should we use elimination? It's really the big question. First and foremost, honestly, you can always use both. There's never a time when you can't use either substitution or elimination, though I would argue that there's very specific times when either I would use substitution or I would use elimination. This is really based on preference. I'll be honest, my preference is always to default to substitution. For some reason, I like it better. Honestly though, over time, addition and elimination has really grown on me as a technique. Let's talk about this first one over here. I'll call this linear system number 1. The question is, which should I use? Again, you can use either. I think it's going to be very obvious for me to use elimination here instead of substitution. If that's not obvious, let's think about this. If we're going to use substitution, we need to isolate one of these variables with one of these equations. Let's just, for instance, let's say I'm going to isolate this first equation for x. So I'm going to do that right now. I'm going to take this 5x minus 3y equals -5, and I'm going to solve this thing for x. I'm first going to add over this 3y, which would give me 5x equals 3y minus 5. Now I'm going to divide everything by 5 to get x by itself. So I get x equals 3/5 y minus 1. The next move would be now to insert this expression for x, this 3/5 y minus 1, in for x into this second equation. Right out the gates, even though I know a lot about mathematics, I don't like this idea at all. Because of this 3/5 here, I'm going to be dealing with fractions the whole time I'm solving for x and y, and I don't see any reason to do that. Yes, the answer might be a fraction in the end, but why would I voluntarily turn this into an equation that has fractions everywhere? I don't like it. I wouldn't do it. And I go back to this. The question is, why is there a fraction here? Well, it's because I'm dividing by this 5. That's what creates the fractional stuff. This 1 didn't turn into a fraction because this -5 divides nicely by the 5. This 3 turned into a fraction. It turned to 3/5 because the 3 doesn't get divided nicely by the 5. So it's a really important thing to understand is if the other coefficients in the equation don't divide nicely by this coefficient that I'm going to end up dividing by, again, I divide by the 5 because I chose to solve this for x. I could have done the same thing with the y, but I would have had exactly the same situation. So, substitution or elimination. I look at this, I look at both these equations, and for number 1, no way. There's no way I would ever use substitution for this. I would always only use addition and elimination. And the question is, why would you use addition and elimination? The answer is simply because it's not set up nicely for substitution. Honestly, that wouldn't work at all. I want to talk about equation number 2 over here though, because this one, when I look at this, the first thing I think is, yes, for sure substitution. That's all I would use here because it's quick and easy and it's set up for it. And what I mean by that is this. I'm looking at this, right away I'm looking at this term y right here that has a coefficient of 1 in front of it. Or doesn't seem like it has a coefficient, but we know it's a coefficient of 1. That is screaming, solve this for y. And the reason that is because to solve that equation for y, there's nothing to divide by. All I'm going to do, and I'll even show it real fast, what I would do is subtract 6x from both sides. I'm going to get a y equals negative 6x minus 32. Right out the gates. One move, that equation is already isolated for y, no fractions, game on. I'm going to take that right now, I'm feeling it. I'm just going to plug that right into this next equation. Plus 2, I'm going to substitute the y up here in this first equation. I'm going to substitute that y with this negative 6x minus 32. I'm going to solve that out. Just give me a second to work out all this math. Add 64 to both sides, so we get 64 minus 19, and we get 45. So we get negative 9x equals positive 45. I get x equals negative 5. So there, I got my x. We all know then the way to find the y. I'm going to take this negative 5. I'm going to plug it in here. So for this, I get y equals negative 6, negative 5 minus 32. Oops. I'll solve that for y, and I get y equals 30 minus 32, negative 2. The solution to the system then is negative 5, negative 2. By the way, just as a quick reminder, always mentioning this, a solution to the system is always two values, a value for x and for y. You never just get x equals negative 5, you always got to find the value for y. Again, these are two variable equations. Any solution has two values. We can write them as an ordered pair. We might want to write it in a cool way, which would be negative 5, negative 2. But we always find one for both values. So, then to finish this conversation real quick, when to use substitution, when to use elimination? I think the best way forward is, if you can use substitution, do it. How do I know I can use substitution? How do I know it's easy? It's when you have a variable with no coefficient or a coefficient of 1 in front of it. If I look over here, every variable term has a coefficient of bigger than 1. All of these are bigger than 1 or different than 1. In the second equation, this is the only term that screams at me that I should use substitution. Otherwise, I use elimination. And just to do one step, I'm not going to solve it all out. If I was going to use elimination for the second one, I just choose one of the variables I want to eliminate. I'm going to choose to eliminate the y. I'm choosing the y in this case because I have a negative and a positive, and I need these to be opposites. I'm going to multiply this equation by 2. I'm going to multiply this equation by 3. That will make this a negative 6, that a positive 6. And so I'll just write this out, show that first move. Here's my negative 6y. Here's my positive 6y. The y's cancel when I add them because they're opposites. I get 19x equals negative 76. 76 divided by 19 gives me x equals negative 4. And I'll just conclude I would solve then for y in the same way by plugging this x value into either one of the original equations. And I get, in this case, that y equals negative 5 when I did this earlier. All right, hope that video helped.